Alright, 2.1, problem 1. Find the domain and range of the relation. Like we discussed in class, domain is going to be all x values and range is going to be all the y values. So in this case, the domain would be, that's a flower bracket, 3 and 4, and the range would be 4 and 5. Problem 2. Determine whether the relation is a function or no. Remember, what is the condition for a relation to be a function? 1x should correspond to exactly 1 and only 1y. So in this case, I'm going to draw it so you can see it much better. I have 3 and 4 in my x's, and I have 4 and 5 in the y's. So I see that 3, 4 is a coordinate point and 3, 5 is a coordinate point. 4, 4 is a coordinate point. 4, 5 is a coordinate point. I see that 1x is going to more than 1 y's here. So this is not a function. Determine whether the relation is a function. And I see that -3, -3, -2, -2, -1, -1, 0, and 0. So in this case, the x's are not repeating, and 1x is going exactly to 1y. So this relation is a function. That is true. This is a function. So is a function. Problem 3. Solve the equation for y and then determine whether the equation defines y as a function of x. So let me go ahead and solve for y first. So my y is equal to 16 minus x squared. The easiest way for me to do is to put it in my calculator and graph it. When I graph it, I would have an inverted parabola, and then I would simply use my vertical line test. Simply draw a vertical line, and I see that the line touches exactly once, so this is a function. In this case, I'm going to solve for y. Y is equal to plus or minus square root of x. And again, I'm going to plug it in my calculator. Remember, I have to plug plus or minus, so I would get square root of x, negative square root of x. This is square root of x. This is negative square root of x. And when I do my vertical line test, the line meets the graph 2 times, so this is not a function. A function. All right? So here I'm evaluating for each of the following. Remember, evaluate means they're telling you, you're putting x into the function and you're checking for the y value. In this case, they gave us the x value, which is -1. So I'm going to put -1 into the function. So -1 squared plus 2 times -1 plus 3. 1 minus 2 plus 3, I end up getting a positive 2. So g of -1 is positive 2. G of x plus 5. That means I am replacing my x with x plus 5. So in the machine, instead of putting x, I am putting x plus 5. So I'm going to have x plus 5 squared plus 2 times x plus 5 plus 3. So when I FOIL x plus 5 squared, I get x squared plus 10x plus 25. So when I distribute, I get 2 times x, 2x, 2 times 5, 10, plus 3. I combine my like terms, I get x squared plus 12x plus 38. Students have a question about what if they should stop here or go further. Remember, the question is not asking you to solve, it's just asking you to evaluate. So instead of x, you're going to replace your x with x plus 5. And again, I did show you how to do problem 4a using your calculators. You can do that as well. Now let's go ahead and find g of negative x. So instead of g of x, I have g of negative x. That is, instead of putting x into the machine, I'm going to put negative x. So let me go ahead. Remember, the machine here is x squared plus 2x plus 3. So let me go ahead and put my negative x into the machine. So negative x whole squared plus 2 times negative x plus 3. So I get x squared minus 2x plus 3. Final answer. They're asking us to graph the function f of x is equal to absolute value of x and g of x is equal to absolute value of x minus 2. And how the graph of g of x is related to graph of f of x. So what I would want you to do is I want you to graph your function f of x is equal to absolute value of x and g of x is equal to absolute value of x minus 2 using your calculators. Students might be having a question, how should you be graphing absolute value in your calculators? So when you go to the graphing section, y is equal to, you're gonna press math tab. You're gonna see math on your calculator on the left hand side, and on the math you're gonna have numbers. You're gonna go to numbers, so it's gonna say absolute value of x, and your other function y is gonna be abs x minus 2 absolute value. When you graph these two in your calculators, you're going to see a graph that would give you a v. This is for the absolute value of x, and this would be absolute value of x minus 2. So the question is, how is the graph g, that is, how is the graph, the second graph related to the first graph? So the second graph is the graph g of x is simply the graph of f of x shifted 2 units down. So it's shifted 2 units down. Use the vertical line test to see if the graph is a function or no. So vertical line test, what do? I simply draw a line and I check if the line is touching the graph more than once. In this case, the line is touching the graph 2 times, so this is not a function. All right? Follow the graph of g and find g of negative 4. Remember what I told you, you always have to be very careful what they're asking you for. So in this function, y is equal to g of x. And they gave me g of negative 4. That means they gave me the x value and they're asking me to find the y value. So what do? I go back to my function. This is negative 4. This point is negative 4. And I'm going to see negative 4 to the graph is this point. What is the respective y value? 2. So when x is negative 4, my y value would be, so negative 4, go all the way to the graph, and then to the y value, which is going to be positive 2. Use the graph from problem 7a above to find the value of x. So they're asking us to find the value of x when g of x is 1. So remember, g of x is 1. G of x is 1. That means they gave me the y value. They're asking me to find the x value. So here my y value is 1. What is the respective x value? I'm going to draw a line across here and come down. The respective x value is negative 2. Use the graph of the function to identify its domain and its range. They're asking us to find the domain and range. You got to be very careful. The first thing you got to look at is the domain. So let's go ahead and see the domain. See, when you look at the graph is going down. That means it's extending. Unlike in the other case here, where it has closed and open circles, open and closed circles here. the graph is simply extending. Remember, if it's an open circle, that means it's not included. Closed circle, included. Open circle, open parentheses, closed circle, closed parentheses. But in this case, we don't have a problem like that. We have arrows telling us the graph has been extending. So first, if I want to find the domain, many of you have questions. So I'm going to see where is the graph going. So I'm just going to extend my graph. And I'm going to see the respective x values. This graph would go on like this, correct? It would go all the way down. And this would be extended. My x-axis and y-axis would be extended. So domain means x value. So what all x values do I have? I'm going to go ahead and draw the x values. I'm going to go ahead and look at the x-axis. So this value is included, this value is included, this value is included with the graph, this value is included, this value. So when I look, my entire x-axis is included. So that means from negative infinity to positive infinity. Remember, infinity always has to be open. Now coming to the range. Range is on y-axis. Domain is on x-axis because they're x values. Range is y-axis because they're y values. So let me see, where does my graph start on y-axis? Do you see a -2? Yes, my graph starts at -2. And if I go on the right-hand side, my graph is straight. That means it's not going up or below y-axis. So it's on -2 constant. But when I go down on the left-hand side, my graph is going down on the y-axis. So it is -2 to negative infinity. -2 is included, so the -2 is included here, -2 to negative infinity. But usually the way they write it is from negative infinity to -2, always from left to right. All right. True or false? The graph of a function may cross x-axis several times. So the graph may have more than one x-intercept. Absolutely. So I'm going to show you. See, this graph is touching x-axis only once. I'm going to show you another graph, a parabola. This graph is touching x-axis more than once. So it's not necessary the graph has to touch x-axis only once. It could be touching 2 times or more than 2 times. So this is a true statement.